Hi everyone, welcome to Organic Insight. In this particular video, I am going to tell about hybridization and what are the effects of hybridization. First of all, we'll know the definition of hybridization. The hybridization is nothing but it is a concept of mixing of atomic orbitals to form new hybrid orbitals. Suppose if orbitals is there, atomic orbitals will mix each other. This process is there, it is called as hybridization. Example, I will take one simple molecule which is methane, right? It is CH4 like this. Here, what will happen? I will just write what is the electronic configuration of carbon atom in like this way. Suppose it is increasing in energy like this. In ground state, how it will be, and in excited state, how it will change. I will write like this. This is 1s, this is 2s, and this is 2p. Total carbon will have the atomic number of 6. Therefore, it will have 6 electrons. 1s2, I will write like this. Then 2s2, then 2p2, like this. This is in ground state. This is in ground state. Suppose if I want to write it in excited state, then what will happen? I have to transfer one electron from 2s, this electron, to 2p. Therefore, how it will look like? It will look like somewhat like this: 1, 1, 1. This is s orbital, right? This is 2s, means s orbital. This is p orbital. These four orbitals, what you are seeing over here, this four orbital will mix. Then one s orbital is there, then 3p orbital is there. What will happen is it will give 4 sp3 hybrid orbitals. Then I can be represent those 4 sp3 hybrid orbital like this. This is hybrid orbital which contains one electron like this. Here I am using one term which is hybrid orbital. What is meant by hybrid orbital? Hybrid. What is meant by hybrid? It is a mixture, right? Here I am telling about 4 sp3 hybrid orbitals is present like that. This means it not contain 100% pure s orbital or 100% pure p orbital. Now, this both the case is not there. It is a hybrid. It contains s character also as well as it contains p character also. Then, how much percent of s character is there in sp3? If I ask, then what you will tell? Let's see here. Here, s p p p. I am writing sp3 like this. Here, suppose total of 100%, how much of s percent is there? Just count. One s is there. Here, second orbital, this is third orbital, this is fourth orbital. 100 divided by 4, how much it is? Each one contain 25% of this. 25% of s character is there. Here, 25% of this p, 25%, and this one also 25%. Total this 3 is the same. P orbital means I have to add all this, then it will give 75% of p character is there. 75% of p character is there, then 25% of s character is there. Okay, now we'll see what is the use of this. I am telling 25% of S character is there. By this, what we can able to conclude? This means more more the percent of S character S character, more the electronegativity. Electronegativity. What is meant by electronegativity? It is nothing but the tendency of an atom to withdraw the shared electrons towards itself. This is called electronegativity. If suppose here 25% is there, suppose if it is 75% S character is there, suppose 75% is there, then between this one 25 and this 75, which is more electronegative character is there, we have to tell the answer more the S character, more the electronegativity, like that. Then I will talk about the bonding in methane, how actually the bond formation will takes place. Here I already discussed that if suppose sp3 is there, carbon atom will be having 4 sp3 hybrid orbital around this, like this I already shown, which orbital, each orbital contains one electron, like this. And another element, which is hydrogen, hydrogen contains 1s1, means only one electron is there. That one I can be representing like this. I will be representing here also with orbital. I will show like this. Here hydrogen, if it is there, one orbital I have to draw like this with opposite sign. Here orbital, then same thing. Here one hydrogen is there, which is of like this. Then what will happen? Each sp3 hybridized orbital of carbon will overlap with the 1s orbital of hydrogen. This one also same, like here also it will happen, here also same thing, and here also orbital will overlap to form carbon and hydrogen bond, like this. Somewhat we have to write like this. This is a simple methane molecule. Suppose what is the bond angle and all, if you ask, for sp3 hybridized carbon, we have to write in 3D, we have to write like somewhat like this. It is tetrahedral geometry. What does it mean? This two bond, which is normal bond I wrote here, which is on the plane, means on the paper. This bond is towards the observer, and this bond is away from the observer. What is the bond angle of this? Suppose here I'm simple, I will take methane like example. What is the bond angle from one CH bond to another CH? That is angle between H, C and H. You have to write it as 109.5 degree. It will be there. Then if suppose what is sp2 hybridization? If I ask like this, carbon atom, same thing, we have to write once again like this. I will write in excited state electronic configuration of carbon atom like this. This is s orbital is there, here p, p and p. Now what will happen? These three orbital will mix to each other to form sp2 hybridized orbital, and this is remains as it is, like that. I will be writing it as like this. It is having a geometry of trigonal planar. That's why I will be writing this is sp, sp2. This is also sp2. This is also sp2, and this is also sp2. I will be writing 3 electrons like this. This whatever the unpaired is there, I will be showing like somewhat like this. Then another carbon also I will be writing same as this is also like this. How the bonding takes place in ethene, I will just show here like this. And this is also one like this I will write. Whatever this 3 orbital, this sp2, this one sp2 as well as this, it is there on the plane of a paper, and whatever the this unpaired like normal, this is p orbital, pure p orbital is there, it is right angle to the paper like that. Now what will happen, this is also sp2, this is also sp2 as well as this is also sp2. Now what will happen, these two carbon atom will form bond. We can show this electrons in opposite direction like this. This two what will happen will form bond, and this orbital will form bond with hydrogen. One more one electron like this. Here also one hydrogen is there, one hydrogen is there. So what will happen to this like unhybridized p orbital? This one sidewise overlapping will be taken place to form one pi bond. I will be writing the structure of ethene somewhat like this. Before words, this is hydrogen is there. Here also one hydrogen is there. Hydrogen, hydrogen. And this is pi bond. Now pi bond will form. This molecule is called as ethene. Now this carbon atom, it is having what bond angle of 120 degree, right? Suppose sp2 hybridized carbon, I am telling this. What about the s character? How much s character is there? Total of 100%. Here one s is there, then 2 p is there. Total 3. I have to divide it. How much it will become? 33.33% of s character is there. Now we'll move on to the next one, which is sp hybridized orbital. How it will look like? The same thing, somewhat it will look like this. Carbon atom which is having electronic configuration like this. This is also s, this is p, p and p. Now what will happen? Only s and p orbital will mix each other to form sp hybrid orbital. Then this, what about these two? It will remain as it is like that. Therefore, if I want to write a simple molecule, this is ethine. We will call it as ethine. I will be drawing like this is one sp2 orbital is there. I will be drawing somewhat like this. Like this it is there. This is like that. Carbon will form bond with each other. Total there are two sp2, right? Two sp, sorry. Two sp hybrid orbital is there. This is one, this is the second one. I will be writing over here like this. This is one p orbital, and again I will be drawing like another p orbital like this. Then what will happen is this two, whatever it is there, it will form two pi bonds, and this the sp hybridized orbital is there, it will form bond with hydrogen like this. Therefore the final structure, we can write it as a carbon is there, one sigma bond is there, and it is attached to two hydrogens on the either side, and two pi bond is there like this. Then if I ask what is the hydrogen, carbon and carbon bond angle, it is looking like 180 degree, a straight line like that. This is 180 degree will be there. What is the s character of sp hybridized carbon atom. If I ask total of 100, one s is there, one p is there, total 2, right? If I ask here, it will become 50% of s character, right? I will be writing like this. Now we'll summarize all those things. In sp3 hybridized carbon, the s character is, here I will write s character. Here 25% is there. In sp2 hybridized carbon, it is 33.33%, and in sp hybridized carbon, it is 50% will be there. Therefore, you can observe here the what is the electronegativity order. If you want to see, it is looking like sp will be having more electronegativity compared to sp2 and then sp3, somewhat like this. Then now we'll discuss about what is the effect of hybridization. Now we'll see about effect of hybridization. The first thing I will take bond length, then the second one is bond strength and bond angle. Now we'll discuss one by one. First one is bond length. Now we know there are three possible hybridization: sp3, sp2 and sp hybrid orbitals like this. Now if I take s character in this, as well as I will take p character. Now here the s character is 25% in case of sp3, and here 33.33%, and here it is 50%. Now the percent of p character is nothing but 100 minus the whatever the s character is there. 100 minus 25 is 75% of s character is, sorry, p character is there. Here 66.7% is there, and here 50% is there. Now if we compare the size of s and p orbital, the size of p orbital is greater, correct? The more the p character, the bond length is greater. That's why here we can see the p character is greater in case of sp3 hybridization. That's why the bond length is also greater in case of sp3 hybridization. How we can write that? We can write it as, suppose if carbon carbon single bond is there, if single bond means it is sp3 hybridized carbon atom, this one also same thing. Then here I can write it as carbon carbon double bond, and here I can write it as carbon carbon triple bond like this. Here the bond length will be greater for single bond, in turn carbon carbon double bond, and the shorter will be carbon carbon triple bond. Then if you, in numerical value, we will give carbon carbon single bond is 154 picometer, carbon carbon double bond is 134 picometer, then carbon carbon triple bond is 120 picometer. We can see the shorter is carbon carbon triple bond like this. Now we talked about carbon and carbon. Suppose if hydrogen is attached to carbon atom of sp3 hybridized like this, I will not write full valency of carbon. Just for simple understanding, I will be drawing structures like this. Like this if it is there. What about the bond length in case of this one? This bond length I am talking about, and this one as well as this one. We know that more the s character, if we move like this, the s character will be increased. That's why the electronegativity of this group is more. It will pull the electron towards itself. Therefore, this bond will be shortened. Here the s character is little less than compared to sp. That's why the bond is little pulled towards this one. And here no such cases is there, only 25% of s character is there. That's why again we can write it in the order like this. I'm talking about carbon carbon, and here I'm talking about carbon and hydrogen bond length. If you if we want to give the numerical value, what is the numerical value for this? It is 101 picometer, and here it is for this one, it is 110. A minute it is, but it is the whatever the order is there, we have to remember that it is 108 picometer, like this. Now we'll move on to the next thing, that is bond strength. Bond strength, we all know that, suppose if carbon carbon single bond, which is lengthier, correct, compared to carbon carbon double bond, like this, if this one is lengthier, it will be easy to break. If we compare with the carbon carbon triple bond, like this is more shorter, more the shorter is there, and which is very difficult to break. That's why bond strength, it will be greater for carbon carbon triple bond, then carbon carbon double bond will come, at last carbon carbon single bond will come. If you want to give the numerical value for this, it will be like here 433 kilojoule per mole, and here 383 kilojoule per mole, and here it is 347 kilojoule per mole. We have to remember the sequence. The bond strength, it will be greater for carbon carbon, because this energy will represent this much amount of energy is required to break the carbon carbon triple bond, like this. The more the bond energy, more the energy required, more the stronger is the bond, like that we can able to understand. Suppose if we want to know about the hydrogen, which is attached to the same thing, carbon, like this, like this. Now the bond energy, it will looking like this bond energy, whatever the C triple bond C and this hydrogen, this bond strength I'm talking about, and it is 507 kilojoule per mole, and this one is 443 kilojoule per mole, and this one is 435 kilojoule per mole. How it is increased, we can give the value exactly like this. This is both, I'm talking here carbon carbon single bond, and here carbon and hydrogen, like this two cases we can see. Then we'll move on to the next thing at last, which is bond angle. Bond angle. Now I will consider here sp3 and here sp2 and here sp. We know that the geometry of the molecule, which is in sp3 hybridized state, it is tetrahedral. It is tetrahedral. In case of sp2, it is trigonal planar, and in case of sp hybridization, it is linear. One example I will take, in case of sp3 hybridized carbon, simple example I will take it as methane. I can write it as like this. And here I will take an example of simple molecule, it is ethene. For sp hybridization, I will take acetylene. Now we all know that if you move like this, the s character will increase, correct? Here the bond angle is 109.5 degree, and here it is 120 degrees there, and here it is 180 degrees there. The bond angle will increase like this. More the S character is there, more bond angle will also be there. I think this video is helpful for you people. Thank you very much for watching.